Medians can be calculated for quantitative and for ordinal scale characters. In case of quantitative characters, the medians can be complemented with the quartiles. Quartiles, as its name sounds, is a statistical term which divides the data into quarters or 4 defined intervals. It basically divides the ranked data points into a data set in 4 quarters on the number line. It is basically an extended version of the median. Medians divides the data into 2 equal parts, which quartiles divide into 4 parts. Once we divide the data, the 4 quartiles will be first quartile or lower quartile, basically separate the lowest 25% of data from the highest 75%. Second quartile or middle quartile, also same as median, it divides numbers into 2 equal parts. Third quartile or the upper quartile separates the highest 25% of data from the lowest 75%. Let's say that we have a data set with n data points. Then we take the quartile number for I, and this is how we get the formula for the quartile. Now let's take a look at the example. So we have values of the amount of time used by 14 students in a quiz competition. First, we arrange these observations in ascending order. Then we use a formula to count the first quartile to find out that the first quartile value should be found between the third and the fourth value. It is 3.75 observation to be exact. We take the third observation's values, it is 12, and add 3/4 of the difference between the fourth and the third values. This is how we define the first quartile value. The second quartile lies in the middle between 7th and 8th observations. So we take the 7th observation value, it is 18, and add 2/4 of the difference between the 8th and the 7th values. This is how we define the second quartile value. The third quartile lies between 11th and 12th observations. In what quarter of the way to the 12th observation to be exact, we take the 11th observation value, it's 33, and add 1/4 of the difference between the 12th and 11th values. This is how we define the second quartile value. So this is how we define the third quartile value. If we subtract the value of the first quartile from the value of the third quartile, we can obtain an interquartile range that serves as a measure of a scale for the median. By dividing the interquartile range by 2, we gain the semi-interquartile range as another measure of a scale. However, it is only appropriate in the case of quantitative character. No adequate differences as regards content can be generated for ordinal scaled characters. Thus, a measure of a scale is pointless for them by definition. In order to visualize quartiles, we use a box plot. It is a reduction of statistical data based on the minimum, first quartile, median, third quartile, and the maximum. The term box plot comes from the fact that the graph looks like a rectangle with the lines extending from the top and bottom. Box plots may also have lines extending from boxes, whiskers indicating variability outside the upper and lower quartiles. Hence the terms box and whisker plot and box and whisker diagram. Whiskers have edges that show the minimum and the maximum. Minimum is the lowest data point excluding any outliers. Maximum is the largest data point excluding any outliers. Outliers must be plotted as individual points behind the whiskers. There are 2 ways to determine outliers according to John Turkheim. The outliers are put outside the borderline situated below the first quartile and above the third quartile. Whenever these borderlines are determined by multiplying interquartile range with 3, we speak about outliers, and if these borderlines are determined by multiplying interquartile range with 1.5, we speak about suspected outliers. As we have seen before, by multiplying interquartile range with 1.5, we can also define minimum and maximum by subtracting the outcome from the value of the first quartile or by adding the outcome to the third quartile value. Here is the box plot built for our example that has to do with the time spent by students in the quiz competition. For the minimum and the maximum shown by virtue of asymmetrical whiskers, we take the lowest and the highest values since there are no outliers within this example dataset. And the quartiles that we counted are depicted by virtue of the box, with the thick line in the middle showing the median. Here is another example. Here are the results of an experiment conducted to evaluate the influence of number of cylinders on the fuel economy rates measured in the miles of distance that a car has covered having consumed 1 gallon of fuel. As we see from this table, 3 cylinders provide the best contribution to the fuel economy rates rise. Now let us summarize. At this point, we can talk about a character from different points of view. From the viewpoint of the frequency calculation, data visualization methods, and measures of location. Different measures of location can be applied to the obtained data depending on the type of the character, qualitative and quantitative. Arithmetic mean calculation is allowed only for quantitative characters with values arranged on an interval or ratio scale. Nominal and ordinal scale characters exclude mean calculation by definition. Medians can be calculated for quantitative and for ordinal scaled characters. In case of quantitative characters, the medians can be complemented with the quartiles. Mode can be used for both qualitative and quantitative characters. Absolute and relative frequencies can be determined for values of all qualitative and quantitative characters, whereas cumulative frequencies make sense only for ordinal scaled or quantitative characters. The graphical illustration of data is different for discrete, ordinal scaled, and qualitative characters. From that for continuous qualitative characters. For continuous quantitative characters. There is the pie chart for nominal scaled characters, which is not appropriate for ordinal scaled and quantitative characters. There is the dot diagram and the bar chart for ordinal scaled characters, and for quantitative characters there is histogram and a box plot. All the described graphical methods can be applied for the observations of a population as well as of a sample. Thank you for your attention.